Good morning. Good morning all the PU students. Today in detail about object-oriented design. So the major object-oriented design process, object-oriented design process and design axiom. So these two important objectives along with logical model that is called class diagram. Object-oriented design, logical model, class diagram. So it is this class diagram is one of the object-oriented design. Primary purpose of the class diagram is to model the static view of the system. The static view is expressed based on the vocabulary of the system. The class diagram can be considered as rich set of UML diagram. So 7 UML diagram are there. The class diagram only it is going to create template and key the coding in the system directly. So since it has various notations, so that directly corresponds to the OO paradigms like inheritance, reusability, polymorphism. Hence this diagram mostly preferred by the coder community at the time of transactions. This is very important. The purpose of the class diagram are summarized below. So design and analysis of static view of the system, describing the functionality performed by the system, illustrate the responsibility of the system, show the static association among the elements of the static view, and foundations for the component and deployment diagram, and facilities for the reverse and forward and reverse engineering. It is only the purpose of the object-oriented design in logical model. So in this object-oriented design performed using class diagram, using logic model is one way to perform, one way to study the object-oriented design. So in this object-oriented design, that is for UML diagram. It is the UML diagram is one of the rich set of UML diagram. So class diagram, structured representation and notation you have to write. In the class diagram, no, 3 compartment class diagram, and first compartment it is class diagram, second compartment is attribute, third compartment is operations. Likewise, you have to draw and mention what is the class. Based on the class, you have to write attribute. So based on the attribute, you have to write the operation. So this is very important. The basic notation is important. Write about class, write about abstract class, write about standard class stereo and non-standard class stereo, class template, interface. Interface is also one of the notations, and objects and data types. So that data types, everything it is there in attribute. And then property and classifier attribute and association attribute, qualifier and multiplicity. Multiplicity means one to one, one to many, many to one. So that we are indicating in object-oriented design. That is asterisk to 1 means many to 1. Asterisk to 0 means many to 1. So likewise, we are indicating operations behavior feature of the class, the simply functionality of the class, and it's specified by the name, type, parameter and constraints for the invoking the associated behavior. And abstract operation constraint and then multiplicity and Visibility is very important. So there only visibility allow the constructing the usage of name element. So in this name element, either in namespace or it is access to the element, it is used with class package generalized element important and package important. So here the type of visibility is public, package, protected and private. UML association. UML association, it is association end and navigatability and aggregator and shared and composite aggregate, and then generalized in association, generalized in UML and inheritance. So and dependency in UML. Likewise, we'll go one by one. Only by logical model you do like this. It is one fulfilled object-oriented design. So you have to draw a class diagram and whatever attribute, whatever the operation, you have to take one separate class diagram or one separate system to draw the class diagram and explain. So I am going to explain about only one class diagram, that is for ticket system, bus ticket system, that is flight ticket system, train ticket system. So this is the common ticketing system. So in that particular subsystem, it is class diagram for the passenger list. Passenger list, what are the things required? Customer name, the title of the customer name, last name, title, and flight date. It is associated with many to many. So that is for customer and flight many to many. You have to search the ticket, you search the rate, all based on the flight number. So that is for many to one. Flight to flight number, it is many to one. So it is one example. Second example, the passenger list, that is flight passenger list, they are displaying last day. So train 20, that is for 4 hours before they are displaying the ticket. So likewise, how the customer title, first name, last name. So it is one to many. The ticket only accessing customer. So the list of the passenger, they are accessing the customer, and coupon anything is there, that is accessing many to one to the flight date and flight number. So likewise, you have to draw the diagram and explain. So one ticketing system, administrator is there, then administrator to operator, administrator to attribute, department ID, department name, member name. So in related to with operation, we add department, we add supporting members, view ticket status wise, view ticket department wise. So likewise, you have to draw the class diagram and explain. The fast way, we'll discuss about object-oriented design process and axiom. So here, the class attribute and methods and association identified during the analysis must be designed for implementation at a data type, as a data type expressed in the implementation language. So here the goal here to design class that we need to implement the system. So after that, so this different analysis model is there. The one of the analysis model is ticketing system. The object-oriented design process. The class identified in object-oriented analysis must be revised with shift in focus on the implementation. Here analyzes design axiom to design class, their attribute, methods, association, structures and protocols. Refine and complete the static UML class diagram by adding the details to the UML diagram. And then refine attribute, refine methods, protocol utilizing the UML activity diagram, refine association between the classes, refine class hierarchy and design with the inheritance, and literate and refine again, design the access layer. Likewise, the object-oriented process will go one after another. Here, OOO design. OOO design diagram, very important diagram. Here, design, class, methods, attributes, and association. So one way applying the axiom, and another design, view, access the layer, and prototype, and another. So here ring type design only, object oriented design process is unified approach. Here unified approach, one after another, it is ring counter type. The user satisfaction and usability usability test based on the use case. Here OO design diagram, it is very important diagram. So you have to draw every time. So before explaining class diagram, you have to draw the OO design diagram and explain. So here another many process are there. So design process, it is simplicity class and relationship, and redundant class, two type of simplicity classes, redundant type class, method class, and literate and refine again, and design and view layer classes. So design and view layer classes, micro level user interface comes under in this. So iterate, we refine the whole design, reapply the design axiom, and then repeat the proceeding steps. So here, so many things discussed in Ali Abrami. This only part. So here object-oriented design axiom. Axiom, two axiom is there, independent axiom and then information axiom. So independent axiom maintain the independent component, and then information axiom maximize the information content of the sign. So this is very important. And corollary. Here theorem is proposition that many, it is not evident but can be proven from accepted axiom. So in this consequence, theorem is valid, it is referent axiom, and deductive steps are valid. So corollary is a proposition so that follow from the axiom or another propositions that has been proven. So here corollary is shown to be valid or not valid in the same manner as a theorem. So this is very important for object-oriented axiom. So in this object-oriented axiom, the maximum amount of the complexity and minimum simplicity and straightforwardness. So that is very important. Corollaries up to 6 corollaries are there. So this is the diagram indicating the axiom 1, 4 corollary, axiom 1. So it is an origins of the corollaries. So axiom 1, corollary 1, 2, 3. Axiom 2 also 1, 2, 3. Axiom 6, it is axiom 2 only. So corollary 5, axiom 2 only. So this is the corollary 1. Corollary 1 is normally the functions of the corollary 1 is the uncoupled design with the uh, let's see information control.